Hey there kiddos, welcome to another video. This one is for Module 3, Lesson 15, and we have word problems today. So it is all about applying everything we've learned in Lessons 1 through 15, and we're getting really close to the end of this module, only a few more pages, really just one more lesson, and then we're done with Module 3. Very exciting as we march through the year. So the directions here: solve the word problems using the RDW strategy and show all your work. Not kidding. Don't do a bunch of mental math and say, oh, I figured it out in my head, because it never really counts. Also, look at the objective for today. It's down here in super tiny letters. Solve multi-step word problems. Assess reasonableness of solutions using benchmark numbers. What does that mean? It's fancy for saying, think about how reasonable it is. Does it make sense? And you can use like rounded numbers to predict or to double check when you get the answer. Woo! And then it's all blurry. And ta-da! Thank you. It's all clear. So let's get started. In a race, the second place finisher crossed the finish line 1 1/3 minutes after the winner. The third place finisher was 1 3/4 minutes behind the second place finisher. The third place finisher took 34 2/3 minutes. How long did the winner take? So if we don't know the winner's time, but you know how races go, you run this race and you get to the finish line and you are the winner. And so that is the zero person, that is the number one, and we don't know the time for the first place finisher. Okay, but we do know that the second place finisher crossed the finish line 1 1/3 minutes after the winner. So if you want to make like a tape diagram type drawing, what you can do is when the winner crossed it, the second place finisher was back here. And this is 1 1/3 minutes after the first one. The third place finisher was 1 3/4 minutes behind this person. So let's just put another tick mark. If this is the second and this is the third, then this chunk of time would be 1 3/4 minutes. Okay, now we do have information about this person, that this person took 34 2/3 minutes by the time they got up here. Okay, so for right now, we can just recognize that that is going to be our starting point. That's going to be our helpful place from which to begin so that we can take off these numbers and get to the winner's time. So what do we do with these amounts? Well, you've got a couple of choices here, and that's the way word problems go. No two people will think about it the same way. Actually, I shouldn't say that. A lot of people will think about it the same way, but everybody won't think the same way. So if I have my 34 2/3, that is my starting point. And in order for me to get back down here, I have to take off this and I have to take off this. It looks like a repeated subtraction problem that I can start to figure out. But what we've noticed and what we learned in earlier lessons is that if you rearrange the terms, sometimes when they have common denominators, you can help yourself out. But I also cautioned you in previous videos about moving things around, because in subtraction, those are not add-ins and you can't just shift around things without consequences. So what you can do is you can look at the whole. The whole is what we're starting with, and realize that we do have to eventually take away these two parts. So what you might notice is that I have thirds here and I have thirds here. I'm eventually going to take this away. I'm not taking it away from this one. I'm taking it away from this one. So why don't we do this first? Do 34 2/3 minus 1 1/3 first. Okay, we'll take this off. So 34 minus 1 is 33. And 2 minus 1 is 1. So now I have already solved this portion, and I have part of my answer. Okay, and we don't have to know the second place finisher's time. That's not what the question is asking. It's saying, how long did the winner take? So now that I have my 33 1/3, I still have to take off the 1 3/4. And I still have to take off the 1 3/4. Now I need to have a common denominator, so I can go ahead and do that. I can also do 33 minus 1 3/4 all in one fell swoop, because noticing that when I have 1/3 minus 3/4, this is bigger. So even if I change these to 12ths now, I'm going to end up with a fraction that I can't subtract from this fraction. So you can get 12ths if you want, and then you can do your subtraction that way. But I'm going to go ahead and do 33 minus 1 3/4 for right now. And remember, we're going to save this and put it back very soon. 33 minus 1 is 32. And then 32, you still have to take away the 3/4. So you end up with 31 1/4. Now let's put back the 1/3. Put it back by adding. Now I need those 12ths. So 31, and if I'm using, go ahead and set that up. If I'm using the other denominator as my scale factor, then 3 is going to be my numerator here, and 4 will be my numerator here. And when I add those, I get 31 7/12. And so once you have taken off both of these mixed numbers, you should end up with 31 7/12 minutes for the winner. So the first place winner took 31 7/12 minutes. So I hope that makes sense. I know it's, kind of moving things around a little bit, and you just kind of have to follow whatever you can draw. But those are the strategies we've learned. So give that a try. All right, let's move on to number 2. I'll straighten this out for you so you don't have to make your head go sideways. John used 1 3/4 kilograms of salt to melt the ice on his sidewalk. Okay. He then used another 3 4/5 kilograms on the driveway. So we got the sidewalk and the driveway, and we have all this salt. If he originally bought 10 kilograms of salt, how much does he have left? This is a classic tape diagram problem. Let's start out with our 10 kilograms of salt, and we have it divided into a few sections. We've got the sidewalk, we've got the driveway, and we've got what's left. Okay, so make 3 little sections. Put in what you know. 1 3/4 for the sidewalk. Notice the amounts, because sometimes in some lessons it'll say and grams or versus kilograms. Driveway is 3 4/5. Don't worry if it's not the right size. It doesn't have to be a certain size. We just know that there are 3 parts. What's left is the question mark. So now you can see I have my total and I have 3 parts. What should I do? I should combine what I know and then take that away from our 10. So it basically helps you set up your problem. So we're going to do 1 3/4 plus 3 4/5. I need to have a common denominator, and hopefully you know that 20ths is our lowest common denominator for 4ths and 5ths. Just happens to be the other number that is the scale factor, so we can multiply 5 times 3 and get 15 here, and 4 times 4 and get 16 there. When you add 3 plus 1, you get 4, and when you add 15 and 16, you get 31. Noticing that I have 31 20ths, which is an improper fraction all by itself, this right here is 1 11 20ths that I have to combine with my 4. When you do that, you get a total of 5 11 20ths kilograms used so far. But that is not the answer to the question. The question says how much does he have left, and that's only these 2 sections that we have calculated. So take your 10 that you know is the total, remove what has been used / dumped out on the driveway and the sidewalk, and we're going to subtract it. Now you know how to subtract from whole numbers because we've been setting our problems up like that for a while. 10 minus 5, first just do that and get 5, but then you still have to take away the 11/20. That's going to put you down into the number 4 with the whatever fractional amount is left. And then remember, to solve these, it's going to go down 1, and then the difference between these two is going to complete the whole. So 4 9/20 kilograms is left of salt. There you go. Okay, so I hope that one's probably a little easier than the first one. Let's do another one. Oh, this is fun. Somebody was bored. Let's think of some silly names. Sinister Stan stole, say that 10 times fast, 3 3/4 ounce of slime from Messy Molly. But his evil plans require 6 3/8 ounces of slime. He stole another 2 3/5 ounces of slime from Rude Ralph. How much more slime does Sinister Stan need for his evil plan? Typical tape diagram. Okay, so noticing that the fractions are kind of in a different order. Okay, so what is the whole here? His evil plans require 6 3/8 ounces. And then we've got that made up of our Messy Molly and Rude Ralph. And this is how much more. So again, I've got 3 sections to my tape diagram. Here is what he stole from Messy Molly. Here is what he stole from Rude Ralph. Here is what we don't know. And it's exactly like the previous problem. We have some given which we need to combine. If some kids will say, can I do repeated subtraction? Can I start taking this away? Yes, you can do that too. If you wanted to do 6 3/8 minus this and then, change this to 8 so it's a common denominator and then get another common denominator, you can do that. But another way, and one isn't necessarily better than the other, another way is to combine everything that you're going to take away, and I usually prefer to do it that way. So that's what we're going to do here. I'm going to take my 3 3/4 and 2 3/5 and get common denominators. You can also just add those whole numbers right away and then only work on those fractions. The opposite denominator is my scale factor, so I can multiply here and get 15 and multiply here and get 12. Because I'm adding, I'm not subtracting, so I don't have to worry about the size of the fractions. 15 and 12 is 27, so I'm going to have 5 27/20, and this in itself is 1 7/20. So when you add it all up, you get 6 7/20. Now this is what's been calculated as far as the stolen slime. But that's not the answer to the question. That's only what you've calculated so far. The total that he needs is 6 3/8. He has this. That looks really close. 6 7/20 is what he has stolen. So I need to find the difference between this mixed number and this mixed number. They're very close. So how much more does he need? Maybe it's not that big, but that's okay. I don't need to change the size of that. What I do need is a common denominator. And when you have something that looks like this, some kids will say, well, I just multiply and I'm going to get, wow, 160. And I would say, gosh, do you really want to do that? Remember that the strategy for using the lowest common denominator is to line up your numbers and skip count. When you do that, you might notice that 40 is a multiple of 8. 16, 24, 32, 40. If you get all the way out there, you'll see that 40 is lower. I don't have to use 160. I can use 40 for both of these. Now, I'm not going to do any subtracting with the whole numbers just yet. I want to show you the size of the fractions and see how close we are. But you could do that. I just want to leave the numbers as they are for just a second. So use the scale factor for each one that corresponds with how many times you had to multiply it. Okay, for 20, we had to multiply by 2, so the scale factor for this side is 2. So here's my 14 for that one. But to get from 8 to 40, the scale factor is 5. So I'm going to multiply these by 5 to get 15. Look at how close we are. 15/40 minus 14/40. 6 minus 6 is 0, so we have 0 whole numbers left anyway. But look at how very close our answer is, and this comes out to 1/40 ounce of slime is still needed. Okay, so some of our fractions are going to be very, very tiny. But that makes sense because if I was adding 3 plus 2, that's 5, and it's almost a full one and almost a full one. That would make a little bit more than 6, which is what he has. So you think about the reasonableness of your solution as you're coming along with these problems, and that seems reasonable. Better get my water out of the way and move on so I could talk about Gavin. Hello, Gavin. Gavin had 20 minutes to do a 3-problem quiz. Not too shabby. He spent 9 3/4 minutes on problem 1 and 3 4/5 minutes on problem 2. How much time did he have left for problem 3? Write the answer in minutes and seconds. Challenge, but also not an extension. So, sounds like a tape diagram, doesn't it? Let's do problem 1, problem 2, and problem 3. He has 20 minutes. That is the total, so always put your total on the top when you make a tape diagram. And then draw what you can. He spent 9 3/4 minutes. That's almost half. Gavin, manage your time more carefully. And 3 3/4 minutes on problem 2. How much does he have left? Question mark. Notice that we have a common denominator. Ooh. Sorry, my bad. 3 4/5. Wow, I just did a boo-boo. 9 3/4 for problem 1 and 3 4/5. Because I was thinking, I didn't remember that being a common denominator. Okay, it's not a common denominator. Fourths and fifths are not the same. How much does he have left? We need to combine these two. So 9 3/4 plus 3 4/5. Let's get a common denominator and combine. First whole numbers, we get a 12, and then we're going to use 20ths and 20ths. Okay, because 4 times 5 is 20. We're going to use this as our scale factor, which means we get 15 here, and we get 16 there. Seems so familiar, right? It's like, didn't we just do that? All very close. 12, and then 31 20ths. This right here is an improper fraction, so we're going to combine that. 20 goes into 31 one whole time with 11 left over out of 20, which means I get 13 11/20 minutes spent on problems 1 and 2. That's not the answer to the problem. That is step 1, which you're like, I've already done 10 things. It's only halfway. 20 minutes is our total. Take away what has been spent because you need to find the difference between what we've done and what we have total. So it's fun and easy to do whole number subtraction. So 20 minus 13, there's your 7, but continue taking away that fractional amount. So 7 minus 11/20, remember how to do it. Go down from the 7 to the 6 because you're in the next one lower. Make up the difference between the top and the bottom of the fraction because that's how you make the whole. And when you look at your final answer, you have 6 9/20 minutes for problem 3. Now that's part of our answer because look, there's one question and then it tells you also have to do writing the answer in minutes and seconds. So now we're going to take our time and we're going to figure out how many minutes and seconds this means. So you take your 20, your 9/20, and break that into time. So think about your clock and how you've got 12 on your clock, okay? You've got 60 minutes. You've got 60 seconds in a minute. You've got 60 minutes in an hour. It's kind of based on 60. So when you look at this 20 and you think, how can I use 20 with 60? Okay, so 20 is 1/3 of your clock, 20, 40, 60. Okay, so if I have 3 parts to make 60, then it's like you're scaling it up. Normally we're scaling it down, but we want to scale this up to show the minutes and seconds. So you need to change it so that it's 60 on the bottom. So I've got this, the minutes are fine. We're going to leave that alone, but what do I do with the 9? If I have my 9/20ths and I want to show this 3 times greater, okay, then I would have 27 out of 60. And so that's showing you that I've got 6 minutes and 27 seconds. These are going to be the seconds here for this problem. So when you want to scale something, you look at what you have, connect with what you know, use the scale that you need to increase this time, the size, and then whatever you do to the bottom, you do to the top at the same ratio. Okay, so your final answer for this is 6 and 9/20 minutes, but that actually works out to be 6 minutes and 27 seconds, if you need to be exact, which you do. Okay, that's a doozy, right? Crazy. Some of them are pretty challenging. Let's do the last one. Okay, Matt wants to shave. He wants to shave time. Matt wants to shave 2.5 minutes off his 5K race time. After a month of hard training, this is the total he wants to shave off, he managed to lower his overall time from 21, don't get confused here, this is pretty confusing, from 21 1/5 minutes to 19 1/4 minutes. So he's gone from here to here. By how many more minutes does Matt need to lower his race time? I love it when they make it grammatically correct, but kids are like, what? Because they're not. Funny how little prepositions will confuse people. So how much more time does he need to shave off in order to achieve his 2.5 minute goal to reduce his time? So let's take a look at this with a tape diagram. 2.5 minutes is the goal to shave off, okay? That's our total goal to shave off. He has lowered his overall time from 21 1/5 to 19 1/4. He's gone from here to here. I need to find the difference between what he had and what he has now. What is the difference here? So let's do 21 minus 19 1/4. Sorry, I was just looking at the size of the fractions, which you should also be doing. This is bigger than this. So I'm going to go ahead and take the whole thing away. Okay, 21 minus 19, 2, but I still have to take away 1/4, 1 3/4. And I need to also put back my 1/5. Let's get 20ths. Hopefully you guys can see that. Sorry, I'll move my book. Scale factor here, scale factor there. And I have 1 19/20 minutes so far. Okay, He lowered his time from here to here, and that makes up 1 and 19/20 minutes. 1 and 19/20 minutes he has done. Bravo. Okay. However, by how many more minutes does he need to lower his race time? That is your question in order to get the final answer. So if you break it into parts, you have your total time minus the new time to get the difference between them, which is what he's taken off so far. Now I need to take the 2.5 and subtract the 1 and 19/20. Oh, I hope these videos are helpful. Click subscribe, come back again. I always try to help you guys out so much. And so now we have 1 and 19/20, which this is almost a whole. So I'm not going to bother with this fraction or getting a common denominator yet. I'm just going to do 2 minus 1 and 19/20, okay, as my first problem. 2 minus 1 is 1, but 1 minus 19/20 still has to be done, and that leaves 1/20. Don't forget to put back your 1/2, which can become 20ths pretty easily by a scale factor of 10. Remember, if you're going to multiply by 10 on the bottom, you have to multiply by 10 on the top. And so that would give you, way down here, oh goodness, you can't even see, 11/20 minutes left, which is about right because he's got 1 and almost 2, and he needs more, and that's about half, 11/20 minutes left before meeting his goal. Yay! Hooray! Crazy problems. I know they're big, but I hope this was helpful, and I'll see you on the next video. Bye for now.